Okay, the cosine rules for angles. So basically, when you're using the cosine rule, in the previous video we looked at doing it for when we're trying to find a missing value, and we did a simple example of that. In this one, we're going to be looking at, instead of a missing side length, we're going to be looking at a missing angle and trying to find a missing angle, I should say. Now, to do this, you need to have 3 side lengths, okay? Otherwise, it won't work, and what you will be finding is 1 angle, okay? So you need 3 side lengths and you need 1 angle for this to work. So, how do we actually do it? So I've got the original formula up here. What we're going to do is we're going to manipulate this and get C by itself, okay? So let's start off by, well, let's remove some stuff. So I'm going to start off by subtracting a squared and b squared from both sides of this equation, okay? So we're going to get c squared minus a squared minus b squared is equal to minus 2ab cos c. Next, I'm going to divide both sides by negative 2ab. So divide by negative 2ab. And that's going to put us with c squared minus a squared minus b squared over negative 2ab. And that is equal to cos c. Okay? Now what we're going to do is we're going to manipulate that left-hand side a little bit. So if I take a factor of negative 1 out from the top and the bottom, or divide through by negative 1, we're going to get a squared plus b squared. So the negatives disappear from those, but the negative gets added to the c squared. And that's going to be over 2ab. Okay, so taking that factor of negative 1 out, and that's going to be equal to cos c. And this is our formula that we use. Okay. You could go a step further and do the next bit as well. But the idea is that this is the formula that you use. To complete the last step, however, that's the one I should say you will see more often. To complete the formula though, to remove this cos from that side, we're going to do the inverse on both sides, okay? So that leaves us with c on the right hand side, or left hand side if I move it across. And if I swap the sides around, cos of minus 1 of a squared plus b squared minus c squared over 2ab. Okay, and then make sure to change it to degrees. So that's pretty much how we do it. Okay, so let's have a look at an example. So find the size of the largest angle of a triangle with side lengths 3, 5, and 7. Now, the way that triangles work, the largest angle is going to be the sides and the angles are in a ratio, okay? So the ratio, we know from the sine rule that the ratio of the angles of the equations, I can't even speak. We know that the ratio of the angle of a triangle and its side are equal, and we know that through the sine rule. So that means that the bigger the angle, the bigger the size opposite, and vice versa. The smaller the angle, the smaller the size opposite. So we can use that fact once we draw our triangle to pretty much spot where our biggest angle is going to be. So we've got one length of 7, but then our other lengths are 3 and 5, which are significantly smaller. Because those angles are because those sides are significantly smaller, their corresponding angles are going to also be significantly smaller. So our biggest angle is going to be the one opposite the 7. Now that we've got that, we can use our cosine rule. Now, we can do it the long way like we did before, or we can just put in our cos theta is equal to a squared plus b, that's not a 2, a squared plus b squared minus c squared over 2ab. So this c here in this equation has to be the 7 in this case, okay, because it's the side that is opposite the theta. A and B are still the sides next to it, but the C is that side that's opposite, and that C has to be the one that's opposite. So substituting our values in, we don't know what theta is yet, so we're going to leave that. 3 squared plus 5 squared minus 7 squared, okay, so that 7 has to be at the end, but the 3 and the 5, it doesn't matter, over 2 times 5 times 3. And again, the A and the B, it doesn't matter which way we do those ones. as long as we've got 5 and 3 and we don't put 7 there. Okay, now to get the theta by itself, we're going to take the inverse cos of both sides, and we can just put this straight in to our into our inverse function to get a value out, and it's going to give us the most exact value if we do it that way. So putting this into our calculator, 3 squared. Okay, so cos of -1, brackets, 3 squared of 5 squared, 3 squared plus 5 squared, I should say, minus 7 squared over 2 times 5 times 3, or 30. Close the bracket off, and that's going to give us theta must be equal to 120 degrees. Spot on. Cool. So that's how we rearrange our value. Oh, sorry. That's how we rearrange our cosine rule to find our angle. So with that, I'll see you guys in the next vid.